Another great source for network-based information is DNS, or Domain Naming Service. This is basically a core name resolution that is used for just about every single organization in existence. It is relied upon heavily by the internet. As a matter of fact, without DNS, the internet wouldn't work at all. So the reason for me saying all that is that it's a very important piece of the puzzle for all organizations. And what makes it so great for us is that it is that core piece of the organization, so it's going to house great information. And DNS servers communicate with each other. And they do so via DNS lookups, recursive requests, and zone transfers so that they can synchronize and communicate their records to each other. There are two extremely common implementations of DNS, and that's Bind, or Berkeley's Internet Name Daemon, and Microsoft's implementation of DNS. Now they differ a little bit, but for the most part, they're still a database full of records that are associated to IP addresses throughout the world or in a single organization. Individual zones are generally owned by one or more DNS servers. So basically, you'll have an authoritative DNS server for a particular zone, which can house multiple DNS records. So the great thing about that is we can actually query the DNS zone owner for a particular website and then set our default DNS server to that system and start enumerating records from that DNS server. So it's definitely a great tool for us, and we're just utilizing the existing functionality of DNS to work against the system owners. One of the greatest tools out there for what we're talking about is the NS Lookup tool. And the NS Lookup tool is present on almost every operating system out there, and it basically provides a simple command line name resolution interface. So we drop into an NS Lookup command, and we can actually use that for on-the-fly zone transfers. So we can initiate the zone transfer from the DNS server, something that would only normally happen between two DNS servers. So we're almost tricking the DNS server into transferring its zone information to us, even though we're not a DNS server. Now, the information that you can gain from a DNS zone transfer is almost endless. There are tons of different types of records. You've got host records, pointer records, service records, mail records, you name it. There's all this information associated there, and we can almost use that to have a one-stop shop for network enumeration and network footprinting. So it's going to be very much like some of the scanning that we did earlier, but we're doing it in a non-intrusive way, because generally DNS servers don't mind doing DNS transfers because it's a built-in feature. It's not going to raise a lot of flags. So let's take a quick look at a DNS zone transfer. So we're going to actually get out of Linux for a few minutes and use the Windows box, because its implementation of NS Lookup is a little bit better than what's on the Backtrack distribution. So the first thing we're going to do is drop into NS Lookup. So we're pulled down into that, and right now our default name server is set to 66.2. And we can change that relatively easily by typing in server and then the associated name of the DNS server that we're looking for. And remember, we're kind of picking on the Advocate web server right now, which is at 66.132. So because we've seen in the past that it's running DNS, we know it will accept our request for DNS and maybe even zone transfers if we're fortunate. So we're going to change a few settings here, and this is going to basically tell my NS Lookup client that I'm looking for any records that exist out there. And we can also accomplish somewhat of the same goal by using all. So at this point, we're going to do an ls, just like we might do in a directory on a Unix machine, and specify D, and type in the name of the DNS records we're looking for. The particular company that we're going to be looking for is secretcompany.sec. And we're going to go ahead and port that into a text file. So it looks like that was successful, and we received 9 records. So we can come out here to the actual dump file that we specified and see what kind of records we got. So here's a couple of great examples here. We can see that the Advocate web server is basically the start of authority for secretcompany.sec, meaning that it is the zone owner of that particular domain name. We can also see A records or host records listed out for various systems that are registered under secretcompany.sec. This is extremely valuable for us. So if we take a look, we can see some of these systems. We've got our Advocate web server, of course. We can see what appears to be a Linux server. And this is definitely interesting. We have two servers called Secret Data Server and Secret Web Server, and they're actually in a completely different network than what we're currently scanning. So this is a great example of, hey, you know what, there's probably some type of high security network that might be interesting for us to get access to. So we might even start turning our head more towards some of these secret servers and seeing what we can find out. And here's another very interesting set of A records. And I want you to notice that this particular WSNet 107A system, we're not really sure what that is yet, but we can see that it's a multi-home system. It actually has what appears to be a network interface on two different networks. One of those being the network that we are currently in. Now, the reason this is especially interesting for us is that we may be able to compromise this system. And once we have, we could use it to compromise the next network in the chain. Because we know the system's on both networks, we can attack it from the internal interface and then make that system our base of operations to continue exploiting systems in other networks. And who knows, that might even lead us into the secret network that we actually don't have access to right now. So, again, just a quick DNS zone transfer netted us a significant amount of information that otherwise would have been very difficult to obtain. Through scanning, it would have been nearly impossible for us to find the two other networks associated with this particular company